Here we're going to talk about this Dirichlet series, sum n from 1 to infinity of the Moebius function mu n over n to the s. So recall that we're defining mu p to be minus 1, mu n to be 0 if n is not square free, and we're going to say that is multiplicative. So these three facts together uniquely determine the behavior of mu, at least on the positive integers, but to write it explicitly, mu n is going to be 0 if n is not square free, 1 if n has an even number of prime factors, and is not square free, and minus 1 if n has an odd number of prime factors, and again also not is square free. Okay, so mu is multiplicative, and that means that to study a Dirichlet series like this, one way we can do it is we can write it as an Euler product. So let's write it as a product over primes, and then we can do the usual thing, 1 plus mu of p over p to the s plus mu of p squared over p to the 2s plus dot dot dot, right? And then in each factor in this product over p, you just pick the power of p you need to build n. But because we said that mu is 0 if n is not square free, then this is in fact just a product over p of 1 plus mu p over p to the s, right? This term and all terms that come after this are 0. And we also know the value of mu p, right? It's minus 1. So this is a product over p of 1 minus p to the minus s. And this we can, in fact, just recognize as this product over p of 1 minus p to the minus s to the minus 1 all to the minus 1. This is one way to write it. And so this is going to be just 1 over the Riemann zeta function. So, I mean, to summarize, sum n from 1 to infinity of mu n over n to the s is equal to 1 over the Riemann zeta function at s.